Planet goes this way, that rocket goes that way. Except that some, in fact many objects, move without moving. Or more precisely, they move without going anywhere. I'm talking objects that spin, revolve, rotate, pirouette, orbit, circle, gyrate, whirl, twirl, cartwheel, and so on. Like a planet around a star, an electron in an atom, or even our solar system going around the gravitational center of the Milky Way. From up close, they're certainly moving, but in the grand scheme of things, that motion doesn't take them anywhere. We can still talk about it though. Just like momentum is a concept that describes how much oomph an object has when it moves in a straight line, angular momentum is a way to account for how much oomph objects have when they're going in circles, figuratively or literally. And angular momentum is simple in theory. Pick a point, any point. Pretend your object is moving in a circle around that point. Figure out how fast the object is moving along the circle, never mind that it probably isn't moving exactly along the circle and that the circle might have to change size over time to follow the object, but anyway, then multiply that speed times the size of the circle and the object's mass. And there you have it, angular momentum. For example, a 2 kilogram, 60 centimeter diameter bicycle wheel going 20 kilometers per hour would have an angular momentum of about 7 kilogram meters squared per second. Is that useful to know? The reason we care about angular momentum is that if you take a bunch of objects that are interacting electromagnetically or gravitationally or whatever, and add up all of their angular momenta into one number, then that total value won't change over time, unless some other objects from outside come in and mess things up. So as another example, the Earth, which is 150 million kilometers from the Sun, orbits at 30 kilometers per second, and has a mass of 6 times 10 to the 24th kilograms, has an angular momentum of 2.7 times 10 to the 40th kilogram meters squared per second. That's 4,000 quintillion bicycle wheels. And this angular momentum stays roughly constant over the course of the Earth's orbit, year in and year out. But what's amazing is that even if the Sun and the rest of the solar system were to suddenly disappear, the Earth would still have that same angular momentum about the point where the Sun was. Without the Sun's gravity, the Earth would of course now move in a straight line, requiring an ever larger imaginary circle as it got farther from the point where the Sun used to be. But as the Earth continued through space, its 30 kilometer per second velocity would also point less and less along the circle, so when you calculated the angular momentum, the decrease in velocity would exactly cancel out the increase in the size of the circle, and you'd always get the same answer, 2.7 times 10 to the 40th kilogram meters squared per second. So even when nothing is rotating at all, angular momentum is still conserved. And that's the beauty of a law of physics. It works, even when you try to break it.